Hello, my name is Rich Howard, owner of Architectural Builder Supply. In this video is to bring you a closer look at the Rixson number L27. This is a floor closer, is what the 27 series. This is an L27, which basically means it's going to be ideally suited for hanging exceptionally heavy doors. Okay. And the purpose of this video will be to give an overview of the 27 series closer, talk about where you'll use it, talk about how you'll install it, talk about its features, talk about its dimensional properties, etc. So let's start with an overview of what this closer is. First of all, the 27 is a single acting and handed. Single acting means the door will go from the closed position in one direction and then closed. Doesn't double act, go back the other way like a cafe style door would. So it's a single acting door like typical butt hung doors would be. It's handed, meaning when you order this, you have to order it the right hand because of the construction of this body is set in such a way that it is set from the factory to swing in one direction. Left hand, right hand. Obviously left hand reverse, right hand reverse. They need to be ordered the correct way. This is intended for exterior or interior doors. An L door is very commonly going to be seen for lead-lined, heavy or high traffic type doors. So if it's lead-lined, that's obviously interior. This will handle doors up to 1,500 pounds. And in my experience, it's unusual to hit that sort of weight when it comes to a lead-lined door, but I've supplied material where on paper the door for sure was going to be 950 pounds, given the thickness of the lead, the weight of that per square foot, etc. Having a 50% margin in the door closer for such an application would be perfect. Just like you would if you were wiring something, you'd want a 50% margin on the power supply versus what you'd ask it to do. I would apply that same logic to a floor closer. I've also noticed that the factory will use these heavier closers on doors that are unusually wide or tall as well to help compensate for that. The factory will tell you that they'd like for you to submit to them the height of the door, the width of the door, how heavy the door is going to be, where it's going to be used so that it can make a proper suggestion to you. Door size and weight guidelines are determined by using the appropriate number of intermediate pivots as well. This is a single acting, and what they haven't told us yet is that it's offset. And what that means, there are two types of floor closers in the sense that there are offset closers and then there are center hung type closers. And the difference is inherently the fact that the vertical axis of pivoting, the imaginary line through the center of your hanging device, whether it be hinges or pivots or floor closers with pivots or some sort of a concealed hinge, the location of that vertical axis of pivoting, a concealed hinge, I'm thinking Sauce or Tectus. They all have vertical axis of pivoting. They happen to move ever so slightly as the door opens and closes. That vertical axis of pivoting moves a little bit. But with a floor closer like this, that would not be the case. The relationship of the vertical axis of pivoting to the door is what determines whether it's offset or center hung. The bottom line is with offset, that vertical axis of pivoting is typically, but not always, 3/4 inches from the face of the door out. So when you're standing on the pull side of the door, if you put your tape measure on the face of the door and came out 3/4 inch, that should be the center of the vertical axis of pivoting, and that imaginary line will go from the spindle, okay, all the way up through any intermediate pivots, all the way up to your top pivot and continue on. That dimension can also be 1.5 inches. So 1.5 inches offset is typical as well, same logic. Now if it's center hung, imagine now that you're not measuring, you're on the pull side. Imagine that you're no longer measuring from the pull side of the door out 3/4, but imagine if that vertical axis of pivoting was down in the center of the thickness of the door. So think of an 1 3/4 thick door that's hung on pivots. those pivots are concealed. You don't see them unless you get on the floor and look below the door, or open the door up to 90 degrees and then look up at the header, and you can see that. Well, when that vertical axis of pivoting is down into the center of the door, the thickness of the door, that's called center hung. You can have those. You can have center hung as well when it comes to floor closers. But those are the two types, offset versus center hung. When it comes to offset, we're dealing with 3/4 or 1.5 inch. This happens to be a 3/4 inch center hung closer that we're dealing with. There would be no 1.5 inch dimension when it comes to an L27, because you're going from the pivot point a significantly greater amount to where the bottom arm of the closer is going to carry all the weight. So you can do 1.5 inch offset floor closers, but the weight will be at the low end of the spectrum when it comes to capacity of Rixson floor closers. Let's continue on now to talking about the size and the door parameters of what we're dealing with, and then we'll go on to volume of use and how to determine the hand of a door. Now, moving on with our review, talking about how heavy does your door weigh. Well, it's going to matter on the width and the height, obviously, and the door thickness. But there's a table in the product catalog below this video that will give you the square foot weight, so you don't really, we don't need to know the width and the height. You can calculate the square foot. So the bottom line is, if you're dealing with a typical 1 3/4 inch thick steel door or wood door, you're about 6.5 or 7 pounds per foot. So if you've got a 3070, you've got 21 pounds times 6.5 for metal, 7 for wood. Aluminum storefront is about 3.5 pounds. Bullet resistant doors are generally about 20 pounds a square foot. So now, if you've got a 21 square foot door and you've got 20 pounds per foot, you can start seeing, wow, doors can get really heavy really fast. So the question really becomes, if you had a bullet resistant door that was 20 pounds per foot and it was 420 pounds, what are you going to use to close that door? A surface closer's not going to do it. Okay? Surface closers are rated for about half of that weight. And I've seen people literally take 2 surface closers and couple their spindles together, but that's not the way to do that. So you can immediately start to see where floor closers get brought into the scenario as it pertains to door weight. If you're dealing with, for instance, just a 1/16 of an inch thick lead, you've got 5 pounds per square foot added to the weight of the door itself. If you add a 1/4 inch lead, you're going to add basically 10 pounds per foot to the weight of the door. Okay. If you had a 2 1/4 inch thick wood door, 9 pounds, plus basically 10 pounds for 1/4 inch lead, you're back at having a really heavy door. If you're getting into some sort of a cladded bronze material, you can be well over 20 pounds, 30 pounds a foot in that sort of scenario. The other area where these lead-lined applications come from is the physical placement or the location of the holes for the screws within the hardware itself. This is an L20. This is the bottom arm. Okay, this is the bottom arm for our right-hand door. Okay, the location of the holes permits a straddling of lead down the center of the door. If you have a door so lead-lined doors, in my experience, have lead down the center, or in my experience, more often they have it, if you had a need of retarding the transmission of X-ray, that the science said you need 1/8 of an inch lead, you would generally see 2 pieces of 1/16 lead underneath each door veneer. And in that sort of scenario, the arm's not wide enough to pierce the lead on either side, but if it were to be in the center, those holes would straddle that piece of lead. So the point of the door weight chart is to give an idea of how weights are calculated so that you can start to understand, yes, floor closers really play a role. Then also we're dealing with the frequency type chart. There is information that tells us that when you're dealing with a volume of large department store entrances or office building entrances, you will easily be at well over 1 million cycles just on an annual basis. And that's where the durability of a floor closer is going to really come into play. We have been involved in repairing floor closers that are several decades old, and our current record is from 1904, in fact, with a repaired floor closer from Rixson, and it's impossible to know how many millions of cycles have occurred on this. So the frequency of use is also going to lead you down the path of having a floor closer, whether it be an unusually large or heavy or thick door, or something that's going to get the kind of volume that is way beyond what a surface closer will ever handle. Moving on to how to determine the hand of the door, Rixson material is only going to be sold as left hand or right hand when it comes to these floor closers. If you have a right hand reverse, you're welcome to order it that way, and I would in fact encourage you to order it that way. When the box comes and it says LH on it, just know the factory will convert right hand reverse into left hand. So left hand or right hand inherently mean doors that swing in. If it's left hand reverse or right hand reverse, that's inherently doors that swing out. And I would think a lot of floor closers you're going to encounter are going to be reverse. So by all means, if you have a left hand out, order that as a right hand reverse, would be the bottom line, so that you are detailing it accurately and so that the factory is obligated to take into account anything that may be important when it comes to whether or not a door swings in or out. Now, the only downside that I've been told on floor closers by a Canadian company, an instructor through industry classes, has mentioned up in Canada they hardly ever see floor closers. And the reason is because the oil that's inside of those floor closers just isn't going to last. The rigors of frozen tundra, and I would not take a position on that either way in terms of saying that the hydraulic fluid in a door closer is going to be suitable for negative 20 degrees for 10 weeks straight and to work reliably. I would only say that someone who's lived in Canada their entire life would have, and who is an AHC expert when it comes to door hardware and hollow metal in particular, would have a very large voice when it comes to the possible downside of where you're not going to see a floor closer. Now, let's move on. Now, let's continue on specifically with the model that we're working on. Now, a summary of the item. We're dealing with a single acting handed interior-exterior floor closer intended for lead-lined, heavy, or high-traffic doors, up to 1,500 pounds. And the asterisk that's in the product catalog from the manufacturer states basically that's calculated when you've got the appropriate number of intermediate pivots. Okay, so intermediate pivots. Well, what they mean for sure is load-bearing intermediate pivots. So you would have to order the proper L series intermediate pivot for your application, the proper quantity to be used based on the door height. Doors up to 90 inch would have one intermediate, top pivot, bottom floor closer, one intermediate pivot. When you get 90 inch and greater, you're going to add one intermediate pivot, and then for every 30 inches after that, you'll add an additional one, and that's how they calculate the load. It's not just the floor closer, it's the intermediates helping carry the weight as well. The product description and features tells us that this is a heavy-duty bottom arm and top pivot with screw holes spaced to straddle the lead lining, as we had discussed earlier. And that, of course, is important because any piercing of the lead renders the door no longer a lead-lined door. The next part of the catalog talks about available for the following lead-lined door thicknesses: 1 3/4, 2 inch, 2 1/4, 2 1/2, or 3 inch. And I'm not sure that they can't do something custom, because kind of custom in pivots and floor closers is what Rixson does. But the reason that's important is because when you have a door, and this arm is for 1 3/4 inch thick door. When you have a door thickness other than that, if you were to use a standard 1 3/4 inch thickness, imagine our 3/4 inch dimension from the vertical center line of pivot to the face of the door. Now, just where my hand is, you can kind of see where the door is going to have to come in line. Well, imagine if your door was 1 3/4 inch, but it was 2 inch, 2 1/4, 2 1/2, 3 inch thick. What's happening is that door is hanging out further and further past the arm, whereas when you purchase a closer made specifically for the proper thickness, or the closer for the thickness of door, this arm physically changes, where this literally moves, gets wider, so that you maintain the straddle pattern of your screws, but also, and I'm not an engineer, but also so that the door itself resides over the center of the arm appropriately, or at least according to the template, so that the arm is bearing the weight of the door correctly. So I've had some people say, hey, I need a lead lock, I got a 2 1/2 inch thick, and I need an L27. Well, it's going to be made to order. What's the lead time? 3 to 4 weeks, let's say. That's no good. I need it tomorrow. Can I use an 1 3/4 inch version? Well, can you force it to fit on there? Sure. Are you going to possibly render your application dangerously incorrect? Yes. I would not. I mean, could you force it to fit on there? Yes. Is it all wrong? Yes, it's all wrong. You have to order the right thickness of unit for the door thickness because of the reasons just mentioned. There is an additional thrust bearing for greater load capacity. Built-in positive dead stop prevents door from swinging beyond the desired opening degree. This is why these have to be ordered to the degree that you're dealing with. 85 degree, 95 degree, 85 degree, 90 degree, 95 degree, or 105 degree. This one's 105. They must be specified that way. They must be. There's no way around that. Separate independent valves for closing speed, latch speed, and back check. And we'll talk about those valves when we get to the installation instructions. Available in 2 versions. Either non-hold open, which this version is, or S for selective hold open, which means basically you can set the closer to operate as non-hold open or hold open. And so if someone wants hold open, it's going to be an S, a selective hold open. Delayed action is available on non-hold open closers, which this one would be, this closer would be a candidate to have a delayed action. We'll talk about that in a moment. Models available to meet the ANSI A117 low ADA compliant low opening force, where a PH is a prefix to the partner, where a PHL for an 8.5 pound of opening force. However, handicap compliance would indicate 5 pounds of force. And I'm very suspect of whether you're going to have a 1,000-pound door with enough closing force to give you an ADA compliant opening force. You know, with a reduced opening force, you have a reduced closing force. Life safety is going to tell us that, or I should say fire safety is going to tell us that the needs of the door being self-closing in a when it's a fire-rated opening will supersede the needs of handicap code, but that would be the only time when you'd be really in a position to have a handicap compliant opening that exceeds the required listed force. I've also found that the behavior out of very heavy doors and handicap compliant is generally something that's not very predictable and reliable. I've had people from the field tell me that the door just doesn't close right. And they describe it in such a way that the door closer is defective. Well, I don't think it's defective. It's just been rendered to be handicap compliant, and that it's not going to have enough closing force on the spring to operate correctly. And especially when you get into a scenario where you have an exterior door with air pressure imbalances in the building, a very large door, It's probably not going to work at all. The cold weather option, the CWF, is available for door closers, and I understand that the viscosity of that oil is conducive to an application where you're going to have cold weather, although my Canadian friend tells me that's a no-go. You can also and should do a sealed closer, an SC, where the body itself is literally going to be sealed against the penetration of the exterior elements. Available with a floor plate or threshold installation. Now, this will come with its own, this will come with a cover plate, okay? This cover plate is going to permit you to install this. You can also, and you will very often as well, see these installed with underneath floor closers. And I have people call and say, I have no idea how this door is closing. I don't see a door closer anywhere, and I know there's not one in the header or in the door. And I say, well, is there a threshold installed? Yeah. Okay, is there a big arm on one end? Yep. Okay, the threshold is, the closer is below the threshold. So Rixson can literally manufacture thresholds that will act as not only a threshold, but act as a cover of the unit as well. And those are always available. For extended offsets, consult the factory, as I had mentioned earlier. A cast iron cement case. I don't know about cast iron cement cases in the sense that I had understood they were doing items that were non-ferrous, like fiberglass, because I've personally replaced these closers, the closer bodies. The bodies were okay, even though they did need to be replaced. What was happening was the door wasn't opening and closing correctly because the bottom case had deteriorated over probably about a 30-year span. That it needed to be, that the body literally moved in the floor. And there, it was an 8-foot door, so there were 2 intermediates and the top pivot. So the closer was still working and closing the door, and the intermediates were still keeping the door where it needed to be. But you could tell every time the door opened and closed, the bottom actually moved because that had completely rusted away. I had understood that those were fiberglass or some non-ferrous based material. This is obviously iron. Now, moving forward, you're going to get vertical door adjustment, but that really comes only in the form of having a couple of shims. With closers, with pivots, there is no forgiveness. There are some products out there that give you some ability to tailor what you're doing in terms of the height. Floor closers are not among them. You're going to get a shim. You're going to get about 1/8 of an inch adjustment. So when they say that vertical adjustment, vertical door adjustment exists, yeah, that's that's when you're going to remove the door, put the shim, and then build it up 1/8 of an inch. The point of all of that is that you must be utterly accurate and spot on when it comes to installing the material, because there is no forgiveness when it comes to the unit being out of plumb, and there's almost no forgiveness when it comes to the overall height being incorrect as well. So be mindful that that's really what's meant there. Now, for archtop doors or applications where an L180 top pivot cannot be used, specify at least 2 ML19 load-bearing intermediate pivots mounted together at the top of the vertical edge. So you're going to very often see Rixson floor closers installed in incredibly outrageously elegant doors, pairs of doors that are arch-topped. There's no way to put an L180, which is what this will come with, a heavy-duty, an L series top pivot. Okay, again, those screws are set to straddle your lead. You have no header to mount the top plate to naturally, nor do you have a surface to mount it to the door. So you're basically going to forego this, and you're going to use a load-bearing intermediate pivot, as indicated, to be able to handle that sort of application. Mounted together at the top of the vertical edge. So, you know, I'm thinking you're going to have 2 at the top, probably 1 in the middle, right? And then down below. And the ML19 is the proper intermediate to use with an L27 closer. It's a load-bearing 19. It's an M19, but load-bearing. But it's, you know, for a lead-lined application. It's for a lead-lined or heavy door or high-traffic door that is appropriate for a lead line that happens to be load-bearing. They have another load-bearing unit as well. Doors 60-inch to 90-inch in height should have one intermediate pivot, and then each for every additional 30-inch. We had discussed that earlier. I had said if you have a 7-foot door, you'll have one intermediate pivot. That goes down. It's technically anything 60-inch and greater would have one. Below 60-inch, you would not have an intermediate, but you wouldn't have a floor closer, I would imagine. For fire-rated openings, up to 3 hour, add the prefix F. The package will be supplied with a steel top pivot, meaning not one made of a non-ferrous base material like brass. We'll certainly give you all ferrous-based fasteners and will be listed as well. And that UL listing is for 1 3/4 thick doors only. That would make sense because I don't think you're going to have a 90-minute rated 2-inch or 2 1/4 thick door. UL labeled door closers cannot have a PH option. They will not supply it both UL and physically handicapped because that reduced opening force gives you a reduced closing force. Therefore, there may be no way, given the circumstances of the opening, that you can permit that to latch, which is probably why they don't permit it at all. For 20-minute labeled doors, add a suffix-20 to your item, furnished with wood and machine screws. Then you can do extended spindles in half-inch increments up to 2-inch longer than standard. Why would you need a longer spindle? Well, that would be because you probably have an unusual door condition, but more likely you have an unusual floor condition. You might have a terrazzo floor, and you might need a special pan for this, where this is going to literally sit below the bottom level of the floor because the floor is not yet there, which means you're going to have to basically extend this out so that it can communicate to the top, so that it can communicate to the bottom arm of your unit, okay? So, incredibly important to review the technical drawing, review the installation and drawing, because there is no way to field retrofit a longer spindle. If you discover that you have the wrong spindle length, there is no field option for that, and the material must be, the body at least, must be reordered correctly. That takes us through the rest of the product description. Let's move forward. Okay, now let's move on to we've got installation instructions and we've got a template to look at. Let's look at the template first. And really the template is just a dimensional overview of the item itself. Can't really say, I can't understate the importance of reviewing all of that so that you understand dimensionally what needs to happen when the item arrives. Initially, there was very little in the way of published documentation when it came to installation instructions. Well, that's changed, but when I first started looking at floor closers in the 1990s, the early 1990s, there was the template only. Looking at the dimensional properties of the item, we see the floor plate, which of course is included, and we will go over a detailed overview of what is included in the package. Generally, it's the notes that are most important on those pages, except on this L27, there is a door size column, along with a reference to the A and B dimensions, which is going to refer to your arm size in the upper right-hand corner. As I was saying earlier, how that width of that bottom arm actually gets larger with the door thickness. And then the dimension from the face of the door to the face of where the arm is going to lie, your B dimension is there. So that's really important so that you know what you're dealing with when it comes to machining the material, or when you send that template to your door supplier and say this is what we're machining it for. Important to note that there's a max lead thickness column there as well. Obviously 19/32 for an 1 3/4 door. That's going to be related to how the distance of these straddled screw hole locations are going to work compatibly with what you're dealing with. you're going to get into thicker lead thicknesses, you're going to get into a thicker door as well. So be mindful of that. So the notes, do not scale the drawing, sure. The right hand is shown. That is most definitely a right hand unit. Dimensions are given in inches, etc. Conversion. Bottom arm drilled to receive, 1/4 20 by 1 flathead machine screws, or number 14 by 2 inch flathead wood screws. Top arm and pivot leaf are drilled to receive the same size. The top pivot is again that L180 that we had talked about earlier. And to underscore the importance of it, the vertical axis of pivoting of the top pivot needs to be utterly plumb with the vertical axis of pivoting here. Rixson does refer to a quick spotter that they have. If you were to pull up the manufacturer's catalog, link below this video to the manufacturer's page, then product catalog, and type quick spotter. If you have more than one of these to do, or if you have one of these to do, I've had people just buy the quick spotter, because what happens with the quick spotter is you'll install your pivot, you'll install the quick spotter into the pivot, and literally you're going to then run your plumb bob down. The quick spotter is a fixture that fits into the top pivot. It doesn't include any nylon string or the plumb bob, but it gives you a way to elegantly attach your nylon string to the quick spotter, drop that all the way down to your plumb bob so that you can utterly accurately mark the location of what's happening with the spindle location, okay, of your closer body. And that's really important to draw attention to as well. I've had people simply take the cement case with the closer body and not look at the template first to realize the door. They proceeded with laying the cement case and the spindle as if it was center hung, and there was no way to mitigate that problem because the spindle's coming up through the bottom of the door, so that body had to be removed, the cement case had to be destroyed, the concrete had to be broken out, recut, repoured, to literally shift that closer body over, you know, whatever, 2 inches, 3 inches. So that underscores the importance of reviewing the template before proceeding. And I don't intend to warn you off of diving into this more complicated hardware. All you got to do is make sure it's plumb and level. And if you can do that, then this closer is going to be right in your wheelhouse of expertise. For wood doors, pre-drill the arm and top pivot holes to prevent splitting, absolutely, before you're running your screws in, of course. If vertical adjustment is required, 2 1/16 of an inch shims are provided. Place shims between the arm and spindle shoulder collar. I saw only one, but we'll go over that in a moment. Max degree of opening, trim permitting, is 105 degrees. Suitable reinforcing by others, lead lining by others. So the other thing to draw attention to is the depth of mortising the bottom arm. They show door mortised 1 5/16 deep for the arm, and that's going to leave you 3/16 of an inch between the top plate and the bottom of the arm. Well, what if you wanted to increase your undercut? Okay, which would be very normal. Then what you would do is decrease your door mortise. So, which makes perfect sense, really. And you can do all of that. In pivot hardware, they literally give you a little more information that says, if your undercut is this, like if your undercut was going to be, you know, 7/16 here, decrease your depth of your prep of your arm from 1 5/16 to 1 1/16. And then, of course, you need to calculate the net door height and the finished frame opening. So if you're ordering this door from the factory, they're literally going to need to know, what undercut are you working with? If you just give them the template, they may just assume it's 3/16, and you might have a situation that will not work, that you need more. You need 3/8, you need whatever. And obviously modifying a lead line door in the field is an absolute no-go. Would be my recommendation based on OSHA. healthy practices when working with such material. So they don't list that very clearly, but that is the relationship as I understand it when it comes to undercut and the depth of the arm. And you'll notice if you were to measure all of that, you know, the thickness of the arm itself, the undercut, and then the amount that they want you to chisel into the bottom of the door, that's all related. Looking at the rest of the template, I don't see anything. Well, no, I do. Upper left-hand corner, 1/8 of an inch minimum clearance required between door and stop. And I can only tell you that you must maintain that along with the 3/16 radius over the edge of the door. I have seen lots of door installations where that was not accounted for. And because of the way that the door closes, I've seen the outside corner of the frame make ever so slight contact, or over time make slight contact with the door. And then what happens is, as the door closes, because you've not held the 1/8 of an inch, you're going to need to be mindful that the manufacturer's catalog is telling you, and other templates telling you 1/8 of an inch. Because if you had a hollow metal door and frame with a 1 15/16 rabbet, and you had a 3/32 of an inch inset, you're below 1/8 of an inch. 1 15/16 minus 1 3/4 door pocket. You're dealing with, well, actually, yeah, you're dealing with not enough is the bottom line. Let me check my math. Yeah, you're dealing with not enough. You're dealing with a 30-second not enough. So be mindful of that. And that 30-second really matters, believe it or not, because over time what will happen is I've seen those doors make contact, and especially if the 3/16 radius isn't done. And then what happens over time as the door, if it's really close to the stop, I've seen it make contact, because over time all that door has to do is move a little bit in terms of the, if it's a wood door, in terms of the preparation, and it can. The screws can get ever so slightly loose. It starts to hit, and then what will happen is the heel edge of the door will hit the face of the stop. That will work to degrade the installation or the preparation of the door itself on the bottom, and then that exasperated over time had hundreds of thousands of cycles. Now you walk up to the door and it makes a sound as if there's something loose in the door or something's creaking or cranking, and it's because the integrity of the door has failed, the block at the bottom, or the wood reinforcing that's been done, or even worse, you've had someone install the door into a bottom rail that was insufficient to take a 1 5/16 deep mortise. I was just at a job on a month ago, a pair of 408s, pardon me, a pair of 308s, mahogany pair matched both sides. Sure enough, one of those two doors was making sound, because you could hear it, and I theorized that they probably took a stock door or ordered a 308 door, did not order it with the proper rail at the bottom, didn't factory order it prepped. And sure, now you're screwing into particle board. There's very little wood left, and it's only a matter of time. Exasperated by the not 3/16 radius on the heel edge of the door. That was clearly shown there. Anyway, the point of the matter is you need to follow this stuff, because Rixson's been making floor closers since Roosevelt was president, and they've got the science figured out. They just, the first Roosevelt, you need to just follow it so that it works splendidly. There's nothing else on there that I can really see to draw to your attention, so at this point let's move forward to the installation instructions. Now let's dig into the installation instructions. And before we go on, a lot of people will balk at the cost of a floor closer, not only for the equipment itself, but generally the lead time, and also what it takes to get one installed. And that's all very valid. However, there are certain applications. Fifth Avenue in New York, a street that is full of bronze and glass doors, and these doors weigh hundreds and hundreds and hundreds of pounds each and are used thousands and thousands of times a day. The only closer that's going to work is going to be a floor closer. And not that you need to have that sort of application to argue a floor closer. You need to have the right application for a floor closer. You're not going to put this onto a door that takes 50 cycles a day because it's the employee entrance. However, when you invest in a floor closer, you are doing just that. You're investing in an application that's going to last decades. We have the ability through our network of repairing the material. So like I've mentioned much earlier in this video, we've repaired stuff that dates back decades and decades, and we do that over and over. Spoke to a client earlier today, in fact, and said his closers were from 1927 from a Masonic temple. And I'm thinking in my head, that's 90 years. And you betcha they got their money out of it. So do you want to put something in that's going to give you the absolute overwhelming win long term when you have a high volume application? Then it's going to be a floor closer. I happen to be partial to Rixson. It's probably because I'm most familiar with them, but I would also argue that they have the full complement and suite of available options when it comes to door size and requirements. Okay, installation instructions. First of all, they start out with a description of closer adjustment. And I think in no particular order it's okay to review all of that, because on page 2 is where they get into the physical installation of the closer. But let's just take it in order and let's go over the closer adjustment. Closing speeds can be adjusted to suit local conditions and requirements. Label on closer face designates the purpose of each adjustment screw. Adjustments are for speed control. So you can see up at the top they've got closing speed, they've got latch, they've got back check, and this is an N, so no hold open. There's literally nothing there. Closing, latch, and back check. So closing is generally referred to as sweep on surface mount closers. So if you've heard the term sweep valve or sweep control, that's what closing is. So basically what they're defining is latch, just from the orientation of a closed door. From closed to 15 degree, that's latch. From 15 degree out to maybe 65 degree or so is going to be close, what they're calling closing speed. Back check is when you get out past that sort of 65. Here they're calling it 70 degree. The back check is used in the open cycle. Imagine you're opening the door on that Fifth Avenue application and the wind just grabs the door and all of a sudden it starts to move quickly. Well, a back check valve is intended specifically to arrest the wild movement of the door when it gets to 70 and beyond. Not to be treated as a dead stop, even though this will dead stop at 105 degree. And that's not to be treated as a dead stop, in my opinion. You should have independent hardware that will, an overhead stop, which of course Rixson makes, that will stop you with that overhead hardware. But arresting the door, slowing it down from that unsafe and dangerous movement when you're dealing with doors that are hundreds of pounds, is what a back check valve is. So you'll be able to control your latch, 0 to 15, your sweep or your closing speed from 15 basically to 70. 70 then out is back check area. Delayed action, if it applies, and this closer does not have delayed action, simply gives you the ability to slow that closer cycle, that closing cycle down from very open to about 65 degree, so that it will take an obscene amount of time if you want it to close. And that's to allow the handicap to get through. It might be appropriate for applications where it's a hospital and personnel need to move people in and out on various devices, wheelchairs, stretchers, things of that nature. The code tells us that for handicap compliance that it cannot be faster than 5 seconds. The sweep valve will absolutely allow you to take that closer and be you'll be able to slow it down for 30 seconds, let's say. But delayed action is specifically intended when you need to get control of that opening out well past the 70 degree mark or so that the door is not in the opening and you're still going through it, so you can really control it. So the rest of the verbiage of this, delayed action valve allows adjustment from full open to 65 degree, delayed action. The closing speed valve allows adjustment from full open to 15 degree. on units without the delayed action feature. You will be able to slow it down significantly. The closing speed valve allows adjustment from 65 degree to 15 degree on closers that have a delayed action. This closer does not have delayed action, so in this sort of event, you are literally going to use that closing speed, because this closer was not ordered as a delayed action version. You're going to use that sweep speed to control that from full open all the way down, or forgive me, without delayed action from full open down to 15 degree. With delayed action, if you order it, it will give you a separate valve that'll go full open to 65. Then after that, your sweep is going to be running the show, because delayed action is going to fall off at that point. Latch valve is from 15 degree to closed. Back check adjustment must be adjusted to vary resistance from light to firm at 60 degree of door open. So don't test your back check from 0 to 59. Check it out at your 60, 70. That's where you need to be able to set that control. If you were to set your backtrack control, if you have a back check closer, which this does, and you push that door, not aggressively, but move it through its cycle, test that back check valve, and you'll absolutely notice, wow, that really slows down. You'll notice that, absolutely. You want it to be positioned or set so that you can arrest a wild door, but not so much that it's interfering with normal operation. If you've got a door that goes to 90 degrees and it's going to hit a perpendicular wall with a wall stop, or not a wall stop, but some means of like an overhead stop, you're not going to want that back check to kick in at 70, because people are going to force that door open, in my experience. Let's move on to closer type next. Now let's move further down to closer type. The closer can be adjusted for an increased closer type. Non-hold open is something that's done at the factory. You have no control over it's being a hold open or non-hold open. Automatic hold open is factory set with no hold open adjustment. And given how this closer is, selective hold open is what we're dealing with as the other option. On-off hold open label will indicate the position of the on-off selector screw. When turned on, closer has automatic hold open at the degree that it's ordered at. When it's turned off, obviously it will not function, and the closer itself would go all the way to 180, trim permitting. Spring power adjustment. This closer can be adjusted for increased or decreased spring power. Those adjustments, if required, should be done by an authorized repair agency. What that means is this is non-serviceable. You cannot affect any change on the spring, although Rixson can, or someone who's authorized to work on those door closer bodies can as well. You might have an application where you have something that's absolutely not handicap compliant required at all. You could have a tunnel between two buildings and there is a tremendous amount of stack pressure that moves, air pressure that moves in this tunnel. You might specifically need an application where the spring is increased to its maximum capacity, basically. Something like that could be done with the factory or with an authorized repair arm of Rixson. Now, staying on page 1, we get back into all of the dimensional properties, which are literally the template. So we won't review any of that again. Page 2, determine the hand of the door. We've discussed that. And let's get into the installation instructions of the closer, except that they talk about the importance of using a plumb line to make sure that the center line of the top pivot pin lines up with the center line of the closer spindle. Crucial. Floor closer case. And they do refer to an adjustable screw pad that's here. That's going to give you a small amount of adjustment. It's nothing that I get calls about, but an adjustable screw pad is provided in that heavy-duty cement case for better load distribution. The pad is adjusted so the heavy-duty closer case is equally supported by the adjustable pad and the case flange pads at the outer corners of the case as shown by X. Pad is staked to keep it from coming loose. So a couple of things. What they're saying is, you've got 4 holes here, 4 drilled and tapped holes. That is for the 4 big giant bolts that are going to go down into it. I have them removed, but here they are. Okay. That pad is there to sit up underneath the door closer body so that the epic weight of not only the closer body, but of course the door, is not resting on these 4 pieces of alone, and something is allowing you to distribute that load a little bit better underneath here. Okay, so you're just going to tailor that so that it makes contact with your closer, but you're going to need to investigate that prior to getting it all set. And when they say that it's staked, that means they've literally taken the screw that's inside of there and they have peened it so that it prevents you from rotating it to a point where it can actually remove itself. Like valves on door closer bodies that are staked, it prevents you from turning them out so far that the set screw comes out, the oil comes out, and the closer is not serviceable at that point. Step 1, locating the closer. We talked about that at length, and the quick spotter is mentioned there as well. Measure 3/16 out from the door jamb, from the rabbet of the frame over towards the center of the opening. Pardon me, I said 3/16, 13/16. And then again, 3/4 inch from the face of the frame, a perfectly plumb imaginary line all the way up to the top pivot. Hopefully where the top pivot is located and you drop your plumb down, it's going to be at 13/16 from the rabbet of the frame, 3/4 out from the door face is where that would be. Allow 1/8 of an inch minimum clearance from the stop of the frame from the face of the stop. Measure door thickness, add 3/4. Measure, allow 1/8 of an inch, measure the door thickness, and then an additional 3/4 inch. So what they're saying is, if you want to position, you know it's 13/16 over, then from the face of the stop, 1/8 plus your door thickness plus 3/4, that's where that plumb bob's got to be right on. Where the lines meet, that determines the center line of the closer, and that's where you got to make sure this spindle is. Okay. Now let's move on to step 2. Install the cement case in the floor. For floor plate application, cement case is set 1/8 of an inch below the level of the floor. What that means is, if you're going to install, believe it or not, the way they packaged the door closer permitted the floor plate to become slightly compromised. And I will relieve that properly. So here's your floor plate. And this is going to literally, of course, mount right on top of everything. This closer was ordered in the 626 finish. And this is stainless steel. There ain't no doubt about that. Okay, that's stainless. So this should be 630, even though I don't believe 630 is listed. However, I would not argue the advantage of having 630 for the faceplate because, you know, there is no, I was just telling someone, there is no more durable finish on hardware than solid stainless with a brushed finish. That's the most durable of natural finishes. Okay, you can affect your change on your valves right through the faceplate. You don't have to remove that. That's going to look very handsomely, just like this. That's what you're going to see. Okay. You're going to make sure the cement case is 1/8 of an inch below the level of the floor to account for the installation of the plate. For a threshold application, the cement case is going to be flush with the floor, and that literally means that your threshold is going to cover the closer body itself. The spindle is going to ride up through a hole that you'll make in the threshold to accommodate the spindle. Okay. Set the cement case in floor and block in position. You're going to create a hole in the floor. You're going to get that cement case put in place. You're going to shim it, make sure it's perfectly in place, absolutely level, and you're going to grout it with cement in the floor. Don't get any cement inside of the cover case itself. they're saying that the closer is going to be in the cement case when you're doing this work, pouring around. Don't get any cement on any of that stuff. You're going to want to carefully cover all that off. Step 3, install the top pivot and closer arm. Install the top pivot per the template in the door, in the header and in the door. The center line of the pivot should line up with the center line of the closer. Use your plumb line as illustrated. If intermediate pivots are used, see the template for intermediate pivots, okay? They very likely are. Although not necessarily, you could be doing a center hung. Install the door closer arm in the bottom of the door per the door template. Mortising for this is really not that big of a deal. You just need to follow the template and make the door look exactly like what the template looks. Once you have this down in position, what we're going to do, give you a little bit of a closer look as to what that's going to look like when it's all said and done. You know, your arm's going to look like that. This is indeed a right hand because the door is going to sit here and it's going to open out that way. And if I were to push on that arm, it'll sure cycle back. Okay. Now, moving to the top of page, step 4, hang the door. Pins point down for right hand closer. They're talking about a wrench that's involved, and I do not see a wrench here. Let's investigate. 4A, 4B, 4C. All right, on the far right-hand side of the final page. Closer is shipped with closing speed valve down. Do not force the valve any further down. That means that it's basically closed. Close down the latch speed valve. Using wrench, turn spindle until wrench is parallel with center line of closer. Install thrust bearing and spindle shoulder collar. Spindle collar. Thrust bearing. Yeah, they say that there are 2 shims. There's only one here. That's your thrust bearing. Set door. Okay, so close down both of the valves using the wrench. Turn the spindle until wrench is parallel with the center of the until it's parallel with the center line of the closer. Set the door on the closer spindle. Do not.
Long story short, after.
Okay. Okay. So set the door on the closer spindle. This is going to be attached to the bottom of the door at this point. You're going to mate these 2 pieces together. Is what you're going to do. Okay. Your intermediate pivots will be separated. Your top pivot will be separated. You'll have the piece parts. You're going to get the door put down onto the spindle, tip the door into the opening, and the point of the matter is those valves are closed down so that there's no involuntary movement of the door at all, because you want it in the closed position at this point. Set the door on the spindle. Do not force door closed while closing speed valve is turned down. So you have to be mindful of that. Now, push item 1, top pivot pin into place. Okay, so once you've got the door set down onto the body, the door gets tipped into the opening, and you're basically going to thread in your portion of your top pivot to connect everything together. If you were to take an Allen wrench and remove that cap, that spindle is going to come out, and that's how you will then bring the pieces together. Bring your top pin in, put your cap down tight, and that's how you lock it together. And you'll do the same at the intermediate pivots. Make sure the cap is tightened securely. At that point, you can start to adjust your closing valve to get the door to close. But what they're saying here, though, So what they're saying, you know, in step 4 doesn't exactly match what I'm necessarily seeing on the closer that I have here. And what I mean to say by that is, you know, the only position this arm is really going to go in is where the closer is basically at a rest position. So what I would probably do is open the valves and get the spindle to a closed sort of orientation. And then I would position the spindle so that it is parallel to the face of the door with the center line of the closer. And you could use the arm for that. And then I would close the valve so that it stayed in that position. Because I'm not seeing, you know, I can put the arm on like this, just out of the box. I can put it on like this. There ain't no reason to change that at all. I can put it on like this. So I'm going to say that this is not shipped from the factory in the orientation that they've expected it, which is no big deal. You're going to bring that to a position where your arm is parallel. There does appear to be a small amount of preload on the spindle. Not exactly parallel, but I would make it parallel and then close my valves. Then set the door down, tip it into place, run my top pivot in, get my intermediate pivots in. Then I would carefully open my valves one turn, cycle the door a little bit, moving on. Step D, close the door to 60 degree or more and turn closing speed valve counterclockwise. That will open the valve up. It will allow it to take over. Open the closing speed valve counterclockwise one turn to increase the speed up closing. Open the latch speed valve counterclockwise one turn. Opening the valve will allow fluid to move. Closing it down will inhibit that movement. That's what gets the closer to move, the door to move. If the door drags at floor, add a shim. Hopefully it doesn't drag. The net door height's got to be spot on. The undercut's got to be spot on. You know, the mortise, the depth of the mortise of the arm. While working door back and forth, tighten arm locking screw securely with wrench. This has some play. This epically huge set screw that's in there is what you're going to use to set that. There is thread lock that I see on there. I don't see a wrench supplied. Put arm cap on closer spindle and secure tightly. Adjust closing and latch speeds for proper closing. That gets us through everything. Let's go over all the rest of the parts that they've given us. That thrust bearing is most certainly going to go down first because that thrust bearing is going to go down over that spindle. That arm's going to sit on top of there. That's a bearing packet in there, and that's going to do all the work that's in there. Your spacer, should you need it, then your arm comes, then your arm cap. A big decorative piece of metal that's literally going to fit over the knuckle of this gizmo. It'll end up looking like that. Cover that all up real nice after that set screw is turned in. After that, there's nothing but screws. There's screws for the faceplate. There are machine screws for the bottom of the door. If you've got a metal door, there's metal screws for the arm to the bottom of the door. There are metal screws for your top pivot, top header and door. You've got wood screws for everything as well. So you've got metal and wood fasteners complete, and that exhausts everything that we have here, and the faceplate as well. Okay. So the bottom line is, I've talked about why and where you would use a floor closer. Spoken my partiality when it comes to Rixson. There are other people out there who make floor closers, that's for sure. I am probably partial initially, again, because I'm more familiar with the product line than others. But if you have a 1,500-pound door, I would familiarize yourself with the Rixson catalog, because there are things that Rixson does that only Rixson does. We just did a job a couple of months ago where we supplied 4 pivots that were rated for 3,000 pounds. 4 of them. In my experience, I have found Rixson to be very accommodating with special requests. You know, initially I thought to myself, well, they really don't publish a lot of data. This is a very highly technical piece of hardware, a floor closer or pivots. The truth of the matter is, after you dive in and you've got that template, you will realize, as I did, everything you need to look at is actually right there. And if you have any business mortising a door for this sort of hardware, you will understand it. If you don't understand it, you may have no business mortising it for that. But there was a time when I had never done it, and it was a very approachable sort of piece of hardware. And that's because, again, of the decades of what they do. Finally, there's a link below this video to the manufacturer's page where you can pull up not only all of the Rixson products that we sell, but a link to the manufacturer's website, as well as a link to the full product catalog. Any questions on the Rixson L27 or any other Rixson product, please feel free to reach out to us. And thank you.